at Team 11, the Librarians. I'm Maheen.
Sure. My name is Shesh.
My name is Darren, and we have been working closely with our client Dr. Teresa and Cody from the UTS Centre of Autonomous Systems. Our project is to redesign the transmission system for the semi-autonomous trolley.
For a long time, libraries have been an essential part of learning in our society. In Australia, every university, school, and suburb has libraries. Transporting heavy books around the library can sometimes be difficult for the staff using conventional library trolleys on a frequent basis. A new method of navigating large numbers of books around the library is being crafted by the UTS Centre of Autonomous Systems. A new semi-autonomous library trolley will assist the staff to transport heavy book loads across the library more easily. From our first meeting with the client, we were able to observe the current transmission system of the trolley and identify the underlying problem. The current transmission system for the trolley consisted of 2 pulleys and a timing belt. However, this setup was not fully functional due to issues which caused the belt to slip. After observing the problem, we began listing out the potential reasons why the belt was slipping. The chosen components were not compatible with the trolley due to high torque loads at initial startup of the trolley. We also determined that there was not enough contact area between the belt and pulley, which meant not enough frictional force to drive the trolley smoothly. During the same meeting, we also discussed and identified the client's needs and wants in order to agree on a final set of deliverables and an evaluation criteria. The main goal of our project was to deliver a redesigned transmission system using CAD models, 3D printed prototypes, and manufacturing drawings for the client to pursue the new design. After getting a deeper understanding of the problem, we were able to move on to the next stage of the project, which was translating it into our design criteria objectives. This included having a fully operational system with a 100% success rate and maintaining the required dimensions. We measured the motor and wheel shaft size, as well as the width of the parts on the wheel and motor shafts. We also had to ensure the center distance between the shafts remained the same in order to preserve the structural integrity of the trolley frame. After we had understood our design criteria, our team began generating various ideas for transmission systems that could be of potential use. Brainstorming was one of our primary tools in this stage, as we wanted to obtain a wide range of ideas quickly and without any conflict. We started with an idea of a direct shaft transmission system, which would have a bevel gear connecting both of the shafts to the motor and wheels so that the power can be directly transmitted. However, this design option was ruled out as it would require too much time to manufacture and also result in changing the structural integrity of the trolley. Our second idea was to add external tensioners with a spring-loaded pin mechanism to adjust the tension of the timing belt and increase the contact surface of the current belt and pulley. But after consulting with our client, we discussed that having such a tensioner would put the system at risk of not obtaining the speed ratio, and it would also tamper with the current trolley structure. Our third design consisted of a simple design using chain and sprockets. Chain and sprockets have been used successfully in various power transmission systems for over a very long period of time. This system allowed us to maintain all of the design criteria without changing the structure of the trolley. We also structured a morphological chart to give us an overview of all our ideas and to help us choose the most suitable option for this problem. In this way, we were able to agree on the chain and sprocket system as the final solution design to present to the client, and they were happy to move forward. In addition to the new design, we also worked with our client to deliver an optional case to cover the transmission system as a measure of safety, which we all agreed upon. The next stage was prototyping. We then converted our final design concept into CAD models and manufacturing drawings in order to manufacture and mount the sprockets onto the shaft. We decided to use spring pins to mount the sprockets on the wheels, as this would be the most suitable option. We then 3D printed all of the parts, including the sprockets and 66 chain links, to see if it could directly mount onto the trolley. After the parts were printed, we decided to mount the prototype onto the actual trolley. This allowed us to get a visual representation of our design and have a first look into how the redesigned transmission system might look like. We also verified the final dimensions with the CAD model of the trolley to ensure they fit. After successfully fitting the prototype to the trolley, we were able to confirm and finalize our solution. We outsourced the metal chain and sprocket components to mount them on the trolley for testing. According to the manufacturing drawings, we drilled holes in the sprocket hubs and the shafts and face milled the hub to achieve a precise fitment onto the trolley. After all the final components were mounted onto the trolley, we did a number of test runs with our client to ensure we had met the evaluation criteria. This consisted of repeating the simulation runs 10 times to calculate the success rate, which the client was happy with. Finally, we handed over our deliverables to the client, which included assembled CAD files, engineering and manufacturing drawings, 3D prototype of the transmission system and case, and a fully functional trolley. Our client was very happy with our progress and the easy-to-maintain design. This project has been a valuable learning experience from which we all learnt a lot and built up our team working skills. Thanks for watching.